So what we're going to discuss in section 1.6 is we're going to be talking about properties involving the unit circle and our trig functions. The first property we're going to talk about is what we call periodic properties. What it means to be periodic is that functions' values become repetitive after a certain cycle. For example, think about months. Months have a period of 1 year because after 1 year, the months begin repeating themselves. So just like these 6 trig functions, they also have a certain period that they become repetitive. So for sine, we can say that the sine of theta is going to become repetitive after 360 degrees. So we could say sine of theta plus 360 degrees times n. And we can let n be any integer. Sometimes you'll see some textbooks use the variable k as well. And again, so n or k can be equal to -1, 0, 1, 2, 3, and so on. Or in radians, we could say it's the sine of theta plus 2 pi n. Cosecant, because they're reciprocals, also have the same period. So we would say the cosecant theta plus 360 degrees times n, or in radians, cosecant of theta plus 2 pi n. Cosine is just like the sine. It has that period of 2 pi or 360 degrees. So we could say the cosine of theta plus 360 degrees times n, which is equal to the sine of a cosine of theta plus 2 pi n. Secant will have the same periodic property as cosine. So the secant of theta plus 360 degrees times n, or in radians, we would say the secant of theta plus 2 pi n. Tangent and cotangent are the only ones that don't have the period of 2 pi. They have a period of just pi. So we would say the tangent of theta plus 180 degrees times n. Or we would say the tangent of theta plus pi n. So tangent and cotangent are the only ones that have a period of pi and not 2 pi. So cotangent would also be pi, which is also going to be equal in radians to cotangent of theta plus pi n. So now when we talk about on page 14 of your notes, the fundamental identities. So the fundamental identities are what we call, first ones are what we call the reciprocal identities. So again, these can be to any power. So it means if it's a sine squared of theta, cosine to the third theta, all of these properties would apply. So the reciprocal identity for sine is going to be 1 over its reciprocal function cosecant. Cosecant would be equal to 1 over the sine of theta. Cosine will be equal to 1 over its reciprocal function, which is secant of theta. Secant of theta is equal to 1 over the cosine theta. Tangent is equal to 1 over the tangent of theta. Cotangent is equal to, 1 over cotangent theta. And then cotangent is equal to 1 over the tangent of theta. Another type of identity that you really need to know is what's called the quotient identities. We talked about from the unit circle that tangent is y over x. And again, we associate the trig function sine with y. So we could say the tangent of theta is the sine of theta over the cosine of theta. Or the cotangent of theta, like I said, is the x over the y. So we could say that this is going to be the cosine theta over the sine theta as our quotient identities. This also, like I said, applies for any power. So we could say that this would be equivalent to sine to the third theta over cosine to the third theta. Just like the cotangent, that would also apply. We could say that this would be cotangent squared of theta, cosine squared of theta over sine squared theta. So like I said, any power of these particular identities would apply.